You noticed on your calculators that you only have log with base 10 and the natural log. And so if we're working with a logarithm that has a base other than 10 or e, we use the change of base formula. And some of your calculators may actually have that in there, some of them don't. So we're going to talk about the change of base formula. If a and x are positive real numbers, I should have brought my book. And a cannot be equal to 1. If we have the log base a of x, that's the same as saying either the log, common log of x over the log of a, or we can use the natural log of x over the natural log of a. Notice the base goes on the bottom of the fraction. You have a hard time remembering which goes on top. The base goes on the bottom of the fraction. William?
Well, so like you could have any base in with the fraction stuff.
And put it into the fraction form. Yes, the change of base formula. For instance,
in the fraction thing, you could have like any base.
Either the common log or the natural log.
Why can't we?
Because that's all your calculator has, is the common log or the natural log. That's the formula that you can use to find the log with any base. So if we had the log base 4 of 25, well, you don't have a log base 4 key on your calculator. But you can write that as the log of 25 divided by the log of 4. Or the natural log of 25 divided by the natural log of 4. So you 4 do it with the common log. You guys do it with the natural log, and let's make sure we get the same answer. What'd you get, Maddie, using the common log?
2.3.
3 decimal places.
2.322.
Okay, what did you guys get with the common log? Got the same thing? 2. All right. So it doesn't make any difference whether you choose to use the common log or the natural log. But what you have to remember in the change of base formula is that the base is in the bottom of the fraction, if that helps. The base is in the bottom of the fraction.
Why can't A be 1?
Okay. Look at log base 2 of 12. Michael, what'd you get?
I got 3.585.
Is that what you got, Iris? Okay, did everybody get 3.585? I want to make sure we're all using the calculator correctly before we move on.
Is this, have you talked about anything else?
That's all we've talked about so far.
Do you have to, like, on your calculator, do you have to put it in a fraction form, or can you just, like, divide?
Yeah, you can divide, because that's, as far as your calculator is concerned, that's the same as a fraction. All right. Some of your calculators have the ability, that nice ability to put it in fraction form real easy. The older calculators don't do that quite so easily. So that's your change of base formula. The base goes on the bottom. That's how I always would remember that. Now, when we first looked at logarithmic functions, we said that logarithms were basically exponents. They were inverses of the exponential function. So we looked at some properties, your warm-up. We looked at, this wasn't the exact problem, but if you had x cubed times x to the fourth, how do we simplify that? What do we do with those exponents, Savannah?
Multiply. Wait, no, we add.
We add them. So when we are multiplying with the same base, we add the exponents. When we if we had x over x to the third, let's do x to the fourth to make it easy so we don't have a negative. What do we do there with those exponents? Maddie?
You subtract 3 from 4.
We subtract. So this would be 4 minus 3, which is 1. And then we looked at one that was similar to this. An exponent raised to a power, we do what with the exponents, Ben?
Multiply.
Multiply. So we'd have x to the 12th. Those same properties can be used, or that thought process used when we're dealing with logarithms. And if you guys saw logarithms last year, you probably did this a little bit. The first is our product property with logs. If we have the log base A, doesn't matter what our base is. It can be a base 2, 3, 4, it can be base 10, it can be the natural log. But the log base A of u times v can be rewritten as the log base A of u plus the log base A of v. Remember when we multiplied with the same base, we add the exponents? It's the same idea here. We're going to add these two. So this is the product property. Sometimes that's helpful if you don't have a calculator handy in simplifying a logarithm. Those of you that will take calculus next year, when we work with logarithms, sometimes we have to expand them like this before we can find a derivative. Yes, ma'am?
Wait, but if you had u, v in the parentheses, wouldn't you be multiplying them?
All right, when we multiplied here, what did we do with the exponents?
Okay.
We added the exponents. So it's that same idea, because remember we said really a logarithm is an exponent, because when we looked at the inverse function, we said x equals e to the y was the inverse of e to the x equals y. This is the inverse. Of course, we rewrote it as y equals the natural log of x. But if we put it in exponential form, it would be e to the y equals x. So in a sense, we could say logarithms are exponents. So we're going to use those same ideas of those properties of exponents. So the product property. The quotient property, using logarithms, says if you have the log base A of u divided by v. Notice this is not the log of u divided by the log of v. It's the log base A of u divided by v. Well, this is equal to the log base A of u minus the log base A of v. The log base A of u minus the log base A of v. When we are dividing with exponents, same base, we subtract the exponents. So here where we are dividing, here we can expand it by subtracting. And then we have the power property, where we're raised to a power. If we have the log base A of u to the n power, we can rewrite this as n times the log base A of u. And a lot of times that helps us in simplifying. Okay, I want to rewrite the natural log of 6 in terms of the natural log of 2 and the natural log of 3. So 6 is the same as 2 times 3, right? So if I have the natural log of 2 times 3, I could rewrite this as the natural log of 2 plus the natural log of 3. And I think you'll have some problems on your homework where they tell you what the natural log of 2 is and the natural log of 3 is. So if you knew that, you could add those two values together to get the natural log of 6. If we still want to write in terms of the natural log of 2 and the natural log of 3, and I have a quotient 2 divided by 27. Okay, I want to write these in terms of the natural log of 2 and the natural log of 3. So the first thing we would do is, if it's division, what does that tell us to do when we start expanding it? Subtract it. So the natural log of 2 minus the natural log of 27. Now I haven't gotten that to the natural log of 3 yet. How could I do that? How can 27 be written in terms of 3?
Yes.
How, William?
3 to power.
Okay, so this could be rewritten as the natural log of 2 minus the natural log of 3 cubed, but we're not finished because that's the natural log of 2 minus 3 times the natural log of 3. We would say that that's fully expanded at that point. We've separated it out as much as we can separate it out. Let's find the exact value, no calculator, of the log base 5 of the cube root of 5. All right, so first thing we have to do is see, is there any other way that we can write the cube root of 5? Katie? Not 5/3. Michael?
Cube root of 5, log 5.
No. Joe?
Would it be 5 to the 1 over 3?
5 to the 1/3. Because the cube root is just raised to the 1/3 power. It's another way we could write it. All right, now we've got our power rule. It says we can rewrite that as 1/3 times the log base 5 of 5. Or you could actually remember the property. What's the log base 5 of 5? 1, so this is equal to 1/3. Or actually at this point, this is one of those inverse properties, so you would see right here that this is equal to 1/3. I don't care whether you use the power rule and rewrite it like I did the second step or just use the inverse rule. Either way works. Let's see what we can do with the natural log. We should be able to solve this without a calculator. The natural log of e plus the natural log e to the 17th plus the natural log of e to the 5th. A couple of ways this could be done. Any suggestions, Oscar?
Yeah.
Christine, you have any suggestions on what we could do?
Is canceling the bases an option?
Like, not really canceling the basis, Molly?
Can you multiply the exponents?
Well, what do you mean by multiplying the exponents?
Well, because they're the same constant, I guess, you can, or not constant, but
Same.
but the base, you can add them together, so when you add exponents, you multiply them?
Okay, I think you're on the right track, but not quite saying it exactly, and it may just be my hearing.
I think Molly's right because for the product property, log A to the UV is the same thing as log AU plus log AV. So we could do ln E 17 times 5, and then you just end up getting
Okay, kinda.
ln
It's
Okay.
e to the 17th times e to the 5th, which we know is the natural log of e to the, what do we do with our exponents? We add them. E to the, okay, and if we get the natural log of e to the 22nd, what does that equal?
22.
That's one way we could do it. Kathleen?
Did you just, like the log, the natural log, it's to the base of E already, so
Mhm.
should you just sort of disregard your natural logs in the E's and then just add 17 plus 5?
You could do that as well.
Why did you just disregard the natural log?
What does this property is that inverse property? Because this is base is E. Or you can think of it this way. We can take that first one and say 17 times the natural log of E plus 5 times the natural log of E. For some of us, one way makes more sense than another. We're more likely to remember it. What is the natural log of E? It's 1. So you just have 17 plus 5, which is 22. So if this makes more sense, do it that way. If you recognize the inverse property that's going on right here on this side, then you can just recognize that natural log of e to the 17th is 17. And the natural log of e to the 5th is 5. And just go from there. So I'm glad you recognize that, Kathleen. That's good. Okay, I want to expand the log of 3x squared y. What's my base here? 10. All right, if we're going to expand this, these are all multiplied, so we have the log of 3 plus the log of x squared plus the log of y. Now the other thing is I'm not finished. I can do one more step because we've got this 2. So that part becomes twice the log of x. So the log of 3 plus twice the log of x plus the log of y. Now it's fully expanded. Okay, you look at this one and see if you can expand this. Okay, if division means subtract, your first step could be the natural log of 4x plus 1 to what power? The 1/2 power. Minus the natural log of 8. So how could I rewrite the first part of that? Joe?
Put the 1/2 in front of the log.
1/2 the natural log of 4x plus 1. Can I do anything with that natural log of 8? Sir?
You could put 2 to the 3rd,
That's 2 to the 3rd.
and then put the 3 in front of the log.
So that would be fully expanded. If you can rewrite one of those values in exponential form, go ahead and do that. Okay? 8 is 2 to the 3rd. All right, let's look at the log of ax to the n. Max, what would this be if I expand it?
It's going to be
What, the what property? You're probably right.
for the,
Product property. So how do I use a product property right here?
you use log A plus log x to the n power.
Plus log x, and if it's to the n power, what can I do instead of writing to the n power?
And the front of it.
Right in the front, and now we're fully expanded. Okay, let's look at a couple that are expanded and see if we can condense them. All right, I want to condense this. So Savannah, what would I have if I condense it?
Well, first you have to make, would it be log of square root of x plus log x plus 1 to the third?
You can do log of the square root of x plus the log of x plus 1 cubed, and then what?
Then, so it would be log the square root of x times x plus 1 to the third.
That would be about all you could do. If you wanted to, you could leave that as x to the 1/2, and that would be fine. Whether you do the square root or change it to x to the 1/2 is fine. But we can't distribute that square root of x because that's raised to the third power. And you'd have to multiply it out and then distribute it. So you can just leave it just like that. That is completely condensed. I guess I'll put another parenthesis to close them out. Let's look at twice the natural log of x plus 2 minus the natural log of x. How would we...
X plus 2 or x minus 2?
Did I say it? It doesn't matter really, but we'll change it to a plus. What would this be? Elizabeth?
Natural log of x plus 2 squared over just x.
And that's all you can do. Notice this is not equal to the natural log of x plus 2 squared over the natural log of x. Don't do that. Okay, that would be incorrect. Michael?
Couldn't you do it again and get a natural log of x squared plus 4 over x?
No. If you multiply that out, it wouldn't be x squared plus 4. It'd be x squared plus 4x plus 4, but you just may as well leave it. Mrs. McKinley says that when Algebra 2, that she tells her students that every time, and she sent me a picture, every time that you do this, a puppy dies. So you don't want to do that.
What is it?
That every time you do that, a puppy dies. Or every time you take x squared minus 4 and you say that just equals to x minus 2, a puppy dies. You don't want to do that. Those are not true statements. And it, yes. So don't do that. We don't want to be accused of killing puppies.
It's sarcasm.
No, it's not
No,
real. It's
not
just-
literally.
Wait, what is
Let's try 1/5 of the log of x plus the log of x minus 2. Normally, you want to work from the inside out. So what would be the first step here, Elizabeth?
Just log x times x minus 2.
Okay, you could do the log of x times x minus 2. And here, if you want to, 1/5 stays here. And then what? Maddie?
Question, would you just go ahead and do x squared?
You
minus
could.
2?
Here you could. You don't have to, but yes, you could.
Why do you need the extra parentheses?
So that you understand the 1/5 applies to all of it. If I did not have those brackets, then the 1/5 would only apply to that.
On the second part. Like,
Oh, here's you open your parentheses for the log, and then I closed it here. So what's the next step? We could move the 1/5 out, or you could even do this if you wanted to. Either way would be fine. And I think we have time for just one more that I want to work through real quick before lunch. The log base 5 of 1/250. So we could rewrite this as a, okay, we'll finish it after lunch and then we'll take the quiz. It's too early to sing Christmas carols.
I hear before Christmas. I hear before Christmas.
All right.
I hear before Christmas song.
Scary song.
It's perfect time for that.
No, we don't do Nightmare Before Christmas. All right, so what is that telling us we're going to use?
Subtraction.
Subtraction. So we'll have the natural log of 5, base 5 of 1, minus the natural log, base 5 of 250. What is the natural log, base 5 of 1?
5.
0.
wait, why is it
Anything to the 0 power is always 1.
Anything to the 0?
So if we rewrote that exponentially, it'd be 5 to the 0, which equals 1.
Oh, but if it's the base and the bottom number the same, then it's one.
Then it's 1.
Okay.
Yes.
I got that.
All right, now here, I'm going to rewrite 250, because we're not finished, because I think we're going to be able to get something with the base of 5. So if we do 125 times 2,
5 to the third.
that becomes minus the log base 5 of 5 to the third plus log base 5 of 2. And what is log base 5 of 5 to the third? So we have a negative 3 minus the log base 5 of 2. Plus, no, minus, we distribute. Have to distribute that negative.
Did you get 5 to the 4?
25 is 5 to the third. Okay. Questions?
What's log? I know what you're, like, I know.
A logarithm is the inverse function of the exponential function.
Why log?
I don't know. That's just what somebody decided to call it, as a logarithm. All right, your assignment will be on page 241. And yes, 16 to 84 every fourth. All right.